Okay, so in class we were working with this function, and this was the rule that you guys found for all of the complex numbers that produce real outputs. I had the groups prove that by plugging it into the equation and then solving and showing that this is now a real number. That's actually more useful than just showing that it's a real number. This is what the output should be for any complex number -2 plus bi. So when we go to actually graph it, you can make your table pretty quickly by just picking x values that have this property where the a is -2 and the b can be anything. So I'll just pick a couple. And this formula actually tells you what the output's going to be based off of what b is. So I can then look at my points, find what the b value is, and plug it in to get the output. That would be exactly the same as going through the whole process of plugging it in, so it's just another shortcut. Here the b is -1. So if I square -1, that's 1, and 3 minus 1 is 2. So you should get an output of 2, which I believe everybody did that one in class because that was in our list. And then -2 plus 0i, b is 0. So you plug in a 0 squared, that gives you 3, which was also our vertex since that is a real number. And then going on from there, if I plug in 2, it's 4, so -1. Okay, so this is our list of values. These are the a's, b's, y values. So when you go to the graph, the x-axis is now going to become the real axis, so it's your a values. The I is the new axis that represents the imaginary parts. We've already always graphed real numbers along the x-axis, so that's the imaginary parts, which was our b in front of the I. And then the y-axis is still y values, which are also expected to be real. We're only graphing real along the y-axis. So these are also real. Okay, so I've got 3 parts, A, B, Y, exactly the same as my table, A, B, Y. Okay, now when you go to graph, you're actually making a box. This is why this is in perspective, because we're graphing in 3 dimensions, so really the points would be sitting in the air, floating in the air. So instead I'm going to use perspective and cubes to represent where those points should be. So here's one way you can do it. To graph that first one, which was -2 minus I, we're going to go -2 on the real axis, and then backwards I on the b axis. So here's where I'm going to use a box. I'm actually going to draw where I would cross 2 on the real axis. That's -1i crossing -2a, and that meets there. And now I'm going to draw that cube upward. Imagine drawing it out of the paper 2 units on the y-axis. Now instead of drawing it out of the paper, we're actually just going to draw it upward along the axis. So from the y-axis, I can draw another line that follows the imaginary axis. Draw that upward. So every line that you draw should be parallel to the axis that it's crossing. And we're going up 2 units. So all of these should be 2 units tall. Now it helps if you draw your scale using a ruler, because then I can actually make it 2 units tall. For me, each of my tick marks is exactly 1/2 inch. So even though I'm working back here away from the axis, I should still have that same scale. Each tick mark or each unit up should be 1/2 inch. So I'm going to go up 1 inch to make those 2 tick marks. And that's the same height as this point here with respect to the origin. And again, if I'm going to complete the cube just to make it clear what is happening here, but you don't have to do the whole cube, of course, when you're drawing these. And then I can connect all my lines. I didn't actually make this one 1 inch tall yet. This should be up a little bit higher. Connect the lines. Okay, so I've made a cube. Hopefully you can see that now, where this is one side, this is one side. The point is that all the dimensions match our ordered pair. So we have a height or a y value of 2, a depth of -1 along the imaginary axis, and a width of -2 along the x-axis. And our point is where all 3 of those dimensions cross at the same time. So this point right here is -2 minus I, comma 2, which is the first point in my table. Now, of course, I don't expect your graph to have a bunch of boxes, so here's a quicker way to do that. I'm going to pick another point to do. All right, the next point in my table is -2. Let's skip that one because that's not going to need a box. Let's do this one down here so it's a different dimension. -2 plus 2i minus 1. So again, we're going -2 along the reals, and I drew this dotted line because all of our points were going to have -2. That was what we had proven. So -2 plus 2i, so this time we're going forward a distance of 2i. Now this is basically a replica of the I-axis, so again, if you made your scale consistent, you can just count out 2i, and for me again, each tick was ½ inch, so that would be 1 full inch out. So that represents where this dimension crosses this dimension. And then we're going to go up, straight up in this parallel to the y-axis, -1. So I guess we're actually going down 1 unit parallel to the y-axis. So I'm going to hold my ruler straight up and down just like the y-axis, and I'm going to go down 1 tick mark, which for me is ½ inch. So if I were to draw in the box for that, so maybe it might help to visualize that it's 3-dimensional. This box has a width of 2 because we went 2 units horizontally. It has a depth of -1 because we went down 1, and it has a what's the other dimension? Oh, this depth, this length of 2 because we went 2 along the imaginary axis. So I'm making this box here with equal dimensions on each side to represent the 3 axes. And this is our point where all 3 of those cross. And so as you graph more, you should see that it starts to form a curve. So I'm going to go ahead and do the next one. We go -2, 0, so not back, but then it goes vertically up 3 units. Again, using my ruler, 3½ inches as parallel to the blue axis as I can. 1, 2, 3. And it's weird because they're so close together, but that's just because we're drawing in perspective, and when you see things in perspective, they'll look like they're overlapping when really they're like behind each other. All right, so that's this point. Sorry about that. This point drawn, this point drawn, and this point drawn. Now -2, 1, 2. So again, -2, forward 1, that's here, and then up 2. So perfectly vertical, 1, 2. Now I'm going to connect my dots. And I actually have another one in the back that I could do for this guy. I could do -2 minus 2i, and that will also map to -1 just to balance this out. So -2, back 2, 1, 2, and then that's equal to -1, so now down 1. Alright, now this is forming a parabola that's a little bit skewed. You can see that it's not symmetric, and that's because this is actually, this side is coming out of the paper, this side is going back into the paper. So imagine you could have depth to your paper. This is actually sitting in the opposite direction of our XY plane. So if we graph our original parabola, we had a vertex here at 2, 3, and then it was graphed up. It has a y-intercept of 7. 1, 2, 3, 4, 5, 6, 7. Let me do this with a better pen. And it sits wide and symmetric because the flat paper represents the XY plane. So this is our original function. It is symmetric on the XY plane. Here is our complex parabola. It's actually coming out of the paper. So imagine that you had an axis coming straight out and it was floating in space here. I recommend that you check out the 3D model that I have posted on the announcement just to double check what that looks like when you can rotate your paper. But this is the best we can get when we're graphing it 2D. Thanks.